I'm going to start talking about a neat exploit or vulnerability. So I originally talked about this vulnerability at the Objective by the Sea conference. So I have some nice slides that detail it maybe better than I can explain it just by talking about it. So it's somewhere down here. So many vulnerabilities. Oh, come on. We'll get there. We'll get there. We'll get there. Okay, right here. So what this vulnerability is previously a zero-day vulnerability that impacted Mojave. It's now patched by Apple. We can see they assigned it CVE 2018-0.4, and here's the link to those slides if you're interested in this. What this vulnerability gave us access to is protected content of the system. So in Mojave, Apple introduced a bunch of new security or privacy features. And we can show this. So let's just hop back to, oh God, you can see all my snapshots, which is fine, but I just have a lot of them, so don't judge. Base. While that's restoring, go back to here. For example, the address book. And that's kind of a good idea. You don't want arbitrary applications to be accessing, for example, your address book. Other things they protected were the camera and the mic. Previous versions of macOS, you could just, any code could start accessing the mic with no notifications. Now there's an authentication prompt and the user has to manually allow that application. I think photos, Safari, cookies, other, again, really sensitive contents that you don't want random applications gaining access to. What this vulnerability did, though, is allow us to access some of that protected content, bypassing Apple's new security privacy protections. So if we come back to here, and let me just pull up some more details about this. We can see, for example, if we try to access the address book, even as root, so the address book, again, with your contacts, and other sensitive information are located in, what is it? I think it is, I wrote it down somewhere. Library, application support, address book. Okay, so if we try to even list the contents of this, so if we try to even tab complete this, we can see that the Mojave basically says, hey, terminal would like to access your contacts. Again, these are the new security enhancements in Mojave that Apple has introduced to protect this content. So we're going to say dope allow, which is going to block us from this. I don't even think we can list the contents of these. Yeah, so even if we do this as root, put in the password, it's going to say it's not permitted, even though we're trying to execute this as root. And again, this is user files. So again, good idea from Apple's point of view. But let's now show how to get around this. So the first thing we're going to notice is that, and I'll grab this file so that we can show it to you. There is a very interesting file called nsdoc.h. nsdoctile.h. And it's really not, okay, it's just a header file, but it says something interesting in here, that is, an application may customize its doc tile when not running via a plugin whose principal class is implemented, blah, blah, blah. The name of this, blah, blah. Okay, this is the important thing. The plugin is loaded in a system process at login or when the application tile is added to the doc. So if you read this from kind of a malicious point of view, like we put on our hacker hats, we can basically think, we read this as, okay, an application can have a plugin, which means an application that we or an attacker can write. That plugin will then be loaded into a system process. Anytime a system process is loading something from an app bundle, meaning something that's attacker controlled, that is wise to take a look at what is loading that. So anyways, we, I Googled this and I was like, okay, how do I write a app with a doctile plugin. Like I had no idea what a doctile plugin was, other than reading in this file. And Apple had an old example of that, which you can download from the internet. So I have this over here. So let us open this in Xcode. Here, I'll drag this to the other screen in a second. So this is Apple's example code, written by Apple. And it basically says, this is a game which demonstrates the use of doctiles, and more importantly, the doctile plugin protocol introduced in 10.6. So we have some example code. We can see there's a main application, and then there's this plugin. So we're just going to compile this. Okay, so that built. So now let's, cool, we have this. We'll drag this to the VM. So let me just move this for a second. Come back to VM. Cool. We execute this. We can see that you can reset or influence the doc tile badge thing, whatever. I have no idea. So, okay, so we've run Apple's application and we're like, okay, cool. Like they said that our plugin got loaded into some system process, but they don't say what system process. So how do we detect what that plugin is and where did that load? So another free utility I wrote is called Task Explorer, and it's kind of like a, let's say, activity monitor on steroids. Let's hop back over here. And so what it does is, for example, for all processes on the system, it shows things like their path, which, that's not that exciting, but it shows their signing. They're signed by Apple. And more importantly, though, it shows if there's, it shows their dynamic libraries, their files, and their network connections. So you can pick an arbitrary process and see what, for example, dylibs are loaded in it. So what we can do is, it takes a while to enumerate because there's a ton of processes that are running. And for each and all the, for example, dylibs that are loaded, it generates the code signing signatures as well. So it's a little slow, needs a little bit of TLC. And there's actually some bugs in Mojave that we will talk about next time that I had to work around, which is kind of funny because Apple really broke a bunch of stuff that has some implications. So if we come to, so some of the things you can do, for example, you can filter tasks. So for example, you can say hashtag, in a VM, it's definitely a little slow, non-Apple. And so this will show you very quickly all tasks on the system, said very quickly, that aren't written by Apple. So this is kind of cool because, if there's a system that you think is infected, you can quickly see all the third-party applications or processes that are running because, most Apple ones are going to be fine. So the other thing we can do is we can come here and we can search and we can say things like unsigned. It's still thinking. And like I said, in the VM, this struggles. Okay, so we can see things that are unsigned. Now, the kernel isn't really actually unsigned. It's unsigned in the sense that it doesn't have a code signature, but it has a hash that's checked on system boot process. So again, we then have the doctile application. This is what we wrote. That's not that interesting. We have some code signing blobs, which I have no idea what those are. But if we scroll down, we see, okay, there's something called doctile, and this is loaded in com.apple.doc.extra. And if we look at the path, we can see it's a little hard to see because of dark mode, but basically says it's loaded from desktop doctile app.app contents plugin doctile plugin blah blah blah. So if we look at the package contents for this application, we can see that, again, this is an example code from Apple. We can see in the plugin directory there is the doctile.doctile plugin, and in there there's something called doctile. And again, that is this file. It's unsigned because we just compiled it and we didn't sign it. And it's loaded into something called com.apple.doc.extra. So now we know what process loaded our unsigned dylib. So we can filter on that, com.apple.doc. There it is, .extra. And again, if we look at dilibs, we can come down here and we can filter dilibs for this process as well. We can say unsigned, NED. And we can see there's only one unsigned dilib, which is our dilib that, again, was taken from our app bundle with no special privileges and loaded into this system process. Now, the system process is running with contexts, with user permission. So this is not an escalation of privileges vulnerability, but we will show something very interesting if we grab this and copy this to the desktop. And let me just grab what's your sign again so we can look at the code signing information. What's your sign? Obviously, this is going to be, oh, look at that, second hit on Google. Awesome. We're interested in the entitlements of this file. So while this is installing, let me briefly talk about entitlements. So entitlements are kind of extra capabilities that can be added to a binary, and they are verified cryptographically, so they can't be spoofed. And what these entitlements do is they convey special permissions about the binary. So for example, you can imagine that something like FaceTime should be allowed access to the camera in all cases, right? Like if Apple blocked FaceTime from accessing the camera, a whole bunch of users would click like deny, and then FaceTime wouldn't work, and they would complain, and they would have to, schedule appointments with the Genius Bar. So Apple was basically like, look, we have a privacy constraint now in Mojave that says that if someone wants to access the webcam, the camera, they have to ask for permission, or there will be an alert. However, if it's something with a special entitlement, for example, FaceTime, that basically gives that application special access and tells the operating system that it doesn't need access to, it's given access by default. And this isn't something that you can add to your own applications. This is something Apple can add. So if we come over here and we look at the signing information for the com.apple.doc.extra, oh, we have to grab, sorry, the whole bundle, because again, it's a XPC bundle. Details of that are not that important other than we want this right here. So let's dump this on the desktop. Okay, now let's look at the entitlements for this. So we can see it's signed by Apple, of course, it's an Apple binary. If we look at the entitlements, we see it has something called com.apple.private.tcc.allow. And the value of that is KTCC service address book. So this is not a documented entitlement, but it is something that says, hey, this is a private entitlement that Apple can give to its own code, its own system binaries. And in this case, it's giving it free access to the address book. TCC is the privacy database. I don't know exactly what TCC stands for, but basically when an application tries, for example, to access the address book or the camera, the system first checks if it's in that TCC database. So again, this is basically telling the operating system that this process is allowed to access the address book without any request pop-ups. It's given carte blanche access. Great question in the channel. Why does the doc need to access your address book? I have no idea. Apple sometimes does things I don't understand. I'd probably guess this is an oversight because when we discuss about the fix, we'll address that. So anyways, what we now have so far is we have a way for an entitled process to load an unsigned dynamic library into its process context. And the important thing to understand about the entitlements are that they are given at a process level. So a process that has an entitlement, for example, one to access the camera or the address book without having to request permission from the user, any code that is loaded in the process context of that program also inherits that. So in other words, if you get a dynamic library that's loaded into that same process, guess what? Your dynamic library also inherits those properties. So what we're going to do is we can write a quick proof of concept for this. And basically what we're going to do is we're just going to copy the address book to the desktop where we can then view it. Obviously, an attacker would, exfiltrate that or do something with that. But we're just going to show that we can do this without any access to this, bypassing that. So I'm going to revert this snapshot because our dilib's already loaded, and we're going to write a new one. We're then going to come back to Xcode. And since this is a dynamic library, what we can do is we can, hold on one second, what do I want to do? We can write a custom constructor that, I don't think I need this one, or this one, that can simply access the files. So when a dynamic library is loaded, usually there's no code that's executed in it until something calls it. For example, the set.tile method. We could put our malicious code in here, but we could also just write a custom constructor. And I have this written already because I'm rather a slow typer. So I'm just going to copy and paste this. And what a constructor will do is it'll be automatically executed whenever the dynamic library is loaded. So as soon as this gets loaded into the entitled com.apple.doc.extra process, the system will check if the dilib has a constructor. And if the dilib does have a constructor, it will automatically execute this. So if you're writing malware and you're writing a malware that's a dynamic library, which you should be doing if you're writing malware because it's very stealthy, it's not going to show up, for example, in a process listing, but you want your dilib to be executed right away, you write a custom constructor. So what we can do is basically just copy the address book to the desktop. Again, I pre-wrote this because I'm lazy. So if we compile this now, see what a cool stream. We give malware hints, we analyze malware. We do all sorts of fun stuff. Okay, so our VM is back and restored. Our plugin with our constructor, again, this will be automatically executed whenever the dilib gets loaded. And again, what we do is we copy the address book, which we illustrated you could not do without permission. We're going to try to copy it to the desktop, which again, in theory, we shouldn't be able to do. But since we're loaded in a entitled system process, we kind of have found a backdoor to access this system or this, this content. So again, let's just copy this app to the system. Oh, come on, VMware. There you go. Okay, we execute this. Oh, look closely. There's something called address book. And what's in address book? Oh, all your address book stuff. Hooray! So again, this isn't like a major security vulnerability, but it is a significant privacy vulnerability. And again, to me, illustrates how sometimes lackadaisical Apple is when they implement new security or privacy features. So they say, okay, hey, your contents should be protected. For example, your address book contents. And I'm like, yeah, that's a good idea. I don't want a random application from the internet to access that, right? Like on your iPhone, it pops up and asks you. So great, great feature to have. But if we look at kind of how Apple implements these things, a lot of times they don't think about it holistically or comprehensively. So, you know, there's something like the doc, which will load a unsigned dilib into its process context, and its process context is entitled, giving whatever's loaded in its process context access to the address book without having to have permission or alert the user. And again, you don't need any special privileges to do this. You don't need to be running as root or anything like that. So again, kind of surprising that Apple, you know, released Mojave with this bug. But, you know, I'm actually not that surprised. This is kind of how Apple rolls. You know, and the OS is very complicated. So my guess is like the people implementing the entitlements for this or this new privacy had no idea about doc tile plugins. And as someone mentioned in the chat, like, why does the doc need this special permission? And why does it need to access your address book? And that's a great question. So what Apple basically did was simply remove that entitlement. So, hey, puppy, come here. So they basically said, hey, you don't need access to this. I guess they looked and and said, hey, yeah, this is silly. So what they did was they just removed that entitlement. So on Mojave Service Pack 1, 10.14.1, they assigned this CVE 2018-4403. And the way they patched it is they basically removed that entitlement from the com.apple.doc.extra. So this will still load those plugins. So this might be an interesting avenue for persistence. So maybe something to look into for malware persistence. But again, being loaded now into this system process, other than it giving you some stealth, which is kind of nice, and maybe some other trust, because again, you're running an assigned Apple process, you don't gain any special permissions because this entitlement has been removed. So again, kudos to Apple for fixing that. But again, it's always good to kind of poke around in the operating system. They literally in their header files describe this vulnerability. I mean, we were the ones that figured out that hey, being loaded in this would give you these extra privileges via the entitlement. But Apple's header files actually kind of led me down this path. So again, a lot of times finding these privacy related bugs, you don't have to necessarily fuzz the kernel. You can just abuse legitimate functionality of the operating system, which a lot of times has been overlooked. All right, so that is a wrap about that. Since we've been streaming for about an hour and 15 minutes, we're going to keep the keylogger detection code for next week. So next week we'll talk about how to write a simple tool, a simple utility to detect keyloggers, which will be kind of neat. And I'm also sure there'll have maybe been some other Mac malware that might have come out that we can talk about. There's also a few other Mojave vulnerabilities, some that are still 0 days that I want to talk about. The one is interesting. It's more just a sad bug on from Apple's. They really it's something they introduced in Mojave that is just painful. But it's something that's unpatched that you can use to kind of crush the system. So it's kind of a funny bug. So maybe we'll talk about that next week. It has been reported to Apple, but currently it is a 0 day. So yes, same time next week, same day, same time. Puppy, come here. Oh, say hi to Havana. Come here. She's sleeping. Come on. She always has to make at least one appearance. Thank you all so much for joining the stream. We can have a few questions and answers, Q&A now. So if you guys and girls want to chat about anything, you have any questions about what we talked about, about the live stream, about the conference, my blogs, anything, Mac stuff, ask away. So the first question is your conference talk available to the public? Yes. So let me just post this. Savannah, you want to stay up here? We gotta get you a bigger chair. She's like, no, I like my bed under the desk. So let me post the link for the talks. All the talks have been uploaded to this page. Those are all the conference talks for Objective by the Sea. Objective by the Sea, again, is the Mac Security Conference. The first one, the inaugural one, was in Maui in November. The second one will be tentatively at the end of May in Europe, somewhere on the sea, hopefully the Mediterranean. So, doggo, 11 out of 10. Yeah, Havana's really the star of the stream. She's the brain. She's actually she's the one that finds all the vulnerabilities. So the reason Apple doesn't pay out bug bounties is because they say she's a dog, and she wasn't invited. Anyways, Objective by the Sea, again, version 2 will be end of spring 2019 in Europe. It's free to attend if you're a Patreon, which you can be for $1. And awesome, it's the world's only Mac Security Conference. We had a ton of awesome speakers. For example, Thomas Reed, director of Mac and Mobile at Malwarebytes. Sarah Edwards teaches at SANS. Mike, who's in this live stream, one of the top Mac security researchers. Jaron from CrowdStrike. Brandon, who just joined Project Zero, talked about an awesome macOS and iOS bug. Richie Cyrus, he works at Spectre Ops doing red team, blue team, macOS stuff. And then Mr. Lin, who is in this chat as well, who works at Facebook and does a lot of really cool stuff. So mark your calendars, or at least pencil in end of May, come to Mac Security Conference. Okay, yes, and the conference videos, the reason they're not posted yet, I have the videos and I have the audio, but I have to put them together. And that's not that complicated of a task, except the audio has a little bit of drift in between, so I can't just put them one on one. But I just contacted an audio professional, and I'm sending him the files, and he is going to work on that. So hopefully in the next week, those will be online. So all the slides are currently online, but again, apologies that the videos are not up yet. This live stream will also be posted to YouTube. My channel is here. I'm still figuring this all out. I'll just post that here. You can see from last week, we had the 2 streams, part 0 and part 1. Probably title those a little more interestingly. But if you missed the live stream from last week, you can catch up on those. Yeah, so are there any other questions? Let me just go. A few other plugs. So a lot of the tools we talked about are on Objective-C. Again, Objective-C is my Mac security website where I write free and largely open source Mac security tools, largely for malware analysis, malware detection. So, we have, for example, Lulu, which is a firewall oversight that tells you if someone's using your mic or your webcam. We saw Knock Knock. Ransomware detects ransomware. Do Not Disturb will tell you if someone's accessing your laptop if you, for example, leave it in the hotel room. Ooh, that's an excellent question. Will you stream your next conference via Twitch? I think we should. We did have a live stream of the conference, again, free to any Patreon subscribers, which again, you can join if you would like. I'll post that link here. And yeah, that's actually a great idea. So more than likely, we will stream the next conference via Twitch or maybe via Patreon, because again, I want to somehow keep it perhaps at least initial access to Patreon supporters. But we will definitely live stream it either way. So I think last time we live streamed it via a YouTube link that I posted on Patreon. But we'll also record that as well and get that posted. Awesome. Well, thank you again so much for joining. Don't forget to follow. And yeah, definitely, I'm going to do this every Tuesday at 6 p.m. PST. I guess that's 9 p.m. Eastern Standard Time. And again, we'll have similar topics. We'll talk about malware, probably some exploits, probably also get into a little more tool development. I'll actually code some of the tools. We can add features, fix bugs, add enhancements. And if there's any ideas that you guys and girls want to see, feel free, if you're like, hey, there's this new malware, let's analyze that. Hey, there's this new exploit someone posted. Can we talk through it? What do you think about this? I'm totally open to suggestions. I kind of love all this stuff, and I also love to talk. So we will always have lots of content. So thank you all, Josh. Thank you. Thanks, Mike. Thanks. I know a lot of y'all here, so really, really appreciate that. And yeah, see you all next week. Super stoked. This is something that we're going to do often. So thank you again. And I will be posting that I will be posting these recordings online as well. And Yeah, let me just give you my Twitter. It's Patrick Wardle. Um, Post that here. If you don't follow me on Twitter, uh, follow me because I post all these links and details. So like when for example this stream has been posted on YouTube, I will tweet that fact. So all right, thanks again. Enjoy the rest of your evenings and see you all next Tuesday.